So we're on section 2 of chapter 16 in your chemistry book. And this chapter is entitled Electrochemical Reactions. So we talked about electric current, specifically going through electrolyte solutions and the flow of the current in a solution from one anode to the cathode, or vice versa. So we have electrolyte solution here. Here's the electrolytes. And of course, the anode is positive because anode draws the negative. Anode means negative wants to go there, so it must be positive. And the cathode must be negative because the positive electrolyte wants to go there. And that's how we have the basic way why electrolytes will carry electric current through it. So before I get to the fish, I want to go back to the questions. We went through electrolysis, electroplating here, which was very significant. We have two electrodes here. One line, the positive electrode, which is the anode. It's the anode is drawing in the positive, but drawing in the negative, so it should be positive. But here we have the cathode, which is charged negative, this negative charged spoon here, and the silver wanting to go into the solution, into the silver nitrate solution, so that it can get over to the negative. So this is silver, Ag means silver, so this silver going through, becoming positive charge, then the positive silver nitrate drawn to silver line this spoon. So we have a spoon that's lined with silver, silver lining. And of course, this same process is used in purifying copper. And we have this example. This is how this is in the factories here, and onto the they raise these copper plates, and as they put them through the solution here, the coppers end up becoming purified. It's raised above the electrolyte cells here. So, and here's the cell here. Here's an example. So here's the impure copper anode, which is, the anode is positive. Remember, it's always positive because it's drawing in the negative, right? And the copper cathode is going to be negative. And so here we have these two plates. This is before electrolysis. Then as electrolysis comes, the copper plates end up, the impurities settle to the bottom of the vat right here. The sludge comes out. And then the purified copper is drawing in the copper from this side, so that now it's more than 99.98% because it's drawing in more copper. So this is how they get the impurities out of the copper, by using this electrolysis situation. Basically, we're calling it the electrolyte refining of copper, which is electroplating. It's the same as this with the silver. So what a picture. So let's go back to I want to go over the questions a little bit here. What constitutes electric current? Well, electric current is the flow of electric charge. Now, distinguish between electric current in a metal and electric current in an electrolyte. In a metal, the electrons are traveling on their own all the way through the metals, so the electrons are traveling. An electrolyte solution, the electrolytes are carrying those electrons in their atom. And so the ions, the electric ions, are actually carrying this the charge. So you have electrolyte, meaning the electrolytes, which are ions carrying the charge. And in a metal, it's just plain electrons going through. So what is electrolysis? Electrolysis is the passage of electric current through an electrolyte solution to cause a non-spontaneous redox reaction. So you're going to electrolysis, you're going to put electric current through these electrolyte solution, so that you can cause a reaction to happen to them. In the process of the redox reaction, you're going to have electricity moving from one site to another site. So electrolysis, the passage of electric current through electrolytes to cause a non-spontaneous reaction. Non-spontaneous means that you made it happen, right? Okay, explain the process that occur at each electrode during electrolysis of molten potassium iodide. Okay, so when we think of that, well, we can go through those steps, but you can, as you go through this straight, you're going to write those half reactions. It's going to be very similar to sodium chloride that we went through. In fact, that's what, to go back to that whole thing, and I went through the whole thing on sodium chloride, but just instead put potassium iodine, which is similar. Potassium is a positive ion, and iodine is a negative ion, and they are very reactive. Just like sodium is a positive ion, really reacted with chlorine. They're in the same categories. And so you're going to have the same type of reactions and half reactions. And you can go back to that situation. Let me just show you what that situation is so you can see the, not water. This situation with sodium chloride, just put in potassium iodine. They're the same type of reaction exactly. Because sodium is +1, and potassium, which is K, which is +1, and iodine is a negative, just like chlorine. So just plug in, bing, 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 and that would be your answer on that one. Let's go back to that next question. Why cannot pure water be easily electrolyzed? I went over there. It cannot be easily electrolyzed because it doesn't have a lot of electrolytes in it. In fact, it has very little electrolytes, so it can't be electrolyzed or electrolyzed. You know, electrolysis cannot occur. It can be electrolyzed. Electrolysis. It's how you have your words. This is electrolyzed, so it can't go through electrolysis because it doesn't have electrolytes in it, right? But it can go through a redox reaction, but not with ions. Electrolysis has to do with ions, and water doesn't form ions, and that's per se as it does. It does actually put hydrogen and oxygen and everything as they come in. They are ionic too. So I'm not saying it doesn't, but it's not, like sodium chloride and potassium iodine and that type of situation. Water is done electrolyzed in a different way in that. So it can't be water. Pure water does not go through electrolysis, right? So why cannot sodium chloride be used as an electrolyte in the electrolysis of water? Because water goes through redox reactions with hydrogen easier than the sodium chloride does, or potassium iodine or whatever. So in that type of situation, you cannot use it in electrolyte in the electrolysis of water. If you want the electrolysis of water to happen, you cannot use sodium chloride, and is what they're saying. Why are metals such as silver and copper used for electroplating? The silver and copper are weaker reducing agents than hydrogen. And so ions are more easily, but their ions are more, they're weaker than hydrogen. So hydrogen's not going to take over, on it. And they are reduced, more easily reduced than water. So in that little era, what they have, they're weaker than hydrogen and they're stronger than water. You get where they'll react, and the silver plating will happen easier and faster. Okay, so this last part I want to go over is just kind of this little article that's written here. It's made me smile, especially if you like fish and water, eels and electric eels and catfish. Anyway, so electric fish. So you see this? This is an electric ray, which is called a torpedo ray. So did you know that some of these animals, the fish here, can actually carry electric current? It says, God created creatures' ability to produce large amounts of electricity in their organs. Such fish are considered fish, they're basically aquatic, are electric rays, which are torpedo rays, electric eels, and mainly in South America are the electric eels, and electric catfish. So animals that have, can carry electric current, well, it's not uncommon, because even in our living tissue, if you do an EKG or EKG to your heart and EEG to your brain, both your heart and brain do carry small voltages of electric current. And that's why they do these tests to see if your electric current and electrolytes in your body are working. So we have electricity going on inside of us. Wow. But these electric fish can produce 50 to 60 volts, and the electric eel onto 500 volts. That's a lot of electricity just in a small animal, right? So reading through this here, basically I'll tell you about the article. They use it as a defense and also as a sensory guide for navigation, because it's very dark and muddy waters where they live. And they also use it to detect, to light up so they could see their prey, and also to scare their predators away, in the midst of muddy water. So there's different reasons for this electric current. But where does this electric current come from? Well, there's cell membranes that have electrolytes in them. Just like we were describing, the electrolytes carrying the current through, and through a selectively permeable membrane that is permeable to potassium and not to sodium. And so in this state, this cell membrane actually is stimulated by a nerve impulse, and this permeability permits the ions, the electric current, to come through. How amazing is that? So the electric eels and the electric eel, the electric organs come in these little cells that are common, that are like in columns, I should say. They're commonly in these common columns, and there's thousands of electrolytes in each one of these series. And this boosts the voltage, and suddenly you have this voltage because of their columns of cells. Just so they have not just one cell, they have a huge amount of these little cells that are kind of like batteries when we describe the voltaic cells. So the electric ray has 3,000 watts of electric power. The most powerful is this electric ray. It goes up to 3,000 volts or 3,000 watts. And the electric catfish has far less current, but a higher voltage, up to 450 volts, because they need the high voltage because they can live in fresh water. And of course, water doesn't conduct electricity as well, so they need more voltage. So in fact, this voltage can knock a human being unconscious, or it can actually kill or paralyze most small animals. That's a big shock, isn't it? The electric organs must fire so that all the electrolytes discharged at the same time. And several 100,000 electrolyte cells are discharged at once. The electric fish must also have a special design to prevent them from being incapacitated or killed themselves. You can imagine if a huge electric current is going through, you think, well, how can they survive that? Well, God has actually built them so that in their brains and their nerves and such are insulated by a lot of fat and connective tissues to protect them from being electrocuted, from electrocuting themselves. So how amazing we have these so-called little batteries, but not just so little. They're not the result of chance, of course. We have the clear testimony of a creative God. But these living batteries can shock you. In fact, the Greeks used to use these electric rays. The Greeks used to say, okay, we're going to take these rays and use shock therapy on people. And so they'd have them step on these rays while they were wet, and they would shock their feet. If they have arthritis in their feet or have problems, and they just think that if they shock their feet in this way, the electric current flowing into our body and shocking us would get rid of arthritis, which it didn't, but they started using this shock treatment on people in Greece way back when we think of like Aristotle and that time, so a long time even before Christ. It's kind of a weird that the Greeks would use this. They maybe even still do, who knows. So anyway, I just wanted to add that to the end of this section, and then we're going to go on to describing voltaic cells, which are batteries.